Okay, so yesterday we started talking about sequences and the notation that goes with sequences, and we were finding terms. When we had a rule for the nth term, we found the first 4 terms. Then we started talking about the recursive definition. We got to that right at the end of class yesterday. What's different about the rule for the nth term versus the recursive definition? What's the biggest difference? With the recursive definition, you have to know the one that comes before it. You have to know the term that comes before. And then your rule tells you what to do with it from there. With the rule for the nth term, you don't have to know the one that comes before it. You take any number that you want. We want to know the 5th term. We want to know the 20th term. We want to know the 112th term. And we take that and put it in the place of n. And it tells us what that value in the sequence is. We're going to do 2 more with the recursive definition where we have to write the rule. I'm going to put those up on the board. So for B, what is our first term? First term is 5. And what is our rule telling us to do? Multiply k with what? With the actual term. We already have the first term in the sequence. So if I want to find the second term, what should I put in the place of k? I'm going to put 1 in the place of k so that I can find my second term. Everywhere I see k, I'm going to substitute in a 1. So here, I'm going to put a 1 in, and we're going to multiply that with the first term. So the second term in the sequence would be 1 times what? 1 times 5. Pedro, you need to put that away for me, dear. So that means the second term in the sequence is 5. All right. Now we know the first and the second terms. I want to find the third term now. So what are we going to put in for k if I want to find the third term? We're going to put 2 in the place of k because 2 plus 1, this will find my third term. So since I'm putting in a 2 everywhere that I see k, we're doing 2 times the second term. How did we find our second term? What did we do to find our second term? 1 times A1, or 1 times 5, right? I could write down 2 times 5, but I'm writing it down like this because I want to be able to see the process. Since we're going to have to write the rule for the nth term, I want to see the things that are staying consistent each time. I want to see the things that are changing each time, and I want to see exactly how they're changing. So that's why I'm taking the time to write down the process. So what is the third term? 10. 2 times 1 times 5. To find the fourth term, what are we going to use for k? 3. A sub 3 plus 1, because this will find the fourth term. So what are we going to be multiplying together? 3. Yes, 3 times the third term, so 3 times 2 times 1 times 5. So what is our fourth term?
20.
It is not 20.
30.
30.
No.
It's not doubling each time.
It's tripling.
Well, this one tripled. The next one would quadruple. And then it would quintuple. So the first four terms are 5, 5, 10, and 30. Let's see if we can write a rule for the nth term, a rule that we could use so that we don't have to know the one that comes before it. So what do you notice as you look at these four terms and how we found them? We multiplied by 5 each time, right? That was always part of it. So A sub n is equal to, I know we're going to multiply by 5. What we multiplied the 5 by, did that stay the same or change each time? 1 stayed the same. Yeah. We kept multiplying by more and more things, right? I want to see if anybody remembers this from last year. If I did 7 times 6 times 5 times 4 times 3 times 2 times 1, does anybody remember what we would call that?
That's like when the number, like the sequence is going like smaller and smaller.
Mm-hmm. But we always stop at 1.
Because you can't go to 0.
Because if we multiplied by 0, what would happen?
Zero.
We'd get 0. So I pick a number to start at, and I multiply by only the whole numbers below that until I get to 1. Does anybody remember what that's called?
Starts with a G, right?
It does not. It starts with an F.
Oh, that's what I thought. Oh,
Factorial. Does anybody remember how to represent factorial?
Oh, there's the exclamation point, right?
Yes. So this would be 7 factorial. Can you guys think of how we might make use of that here?
Function rule.
That can become part of our function rule because each time we're multiplying by, like when we went to find the fourth term, it was 3 times 2 times 1. For the fifth term, it would be 4 times 3 times 2 times 1. For the sixth term, it would be 5 times 4 times 3 times 2 times 1. Let's see. If I do n factorial, why would it be n minus 1? Yes. Let me write this down and then I'll show you guys. When we went to find the second term, we multiplied by 1. When we went to find the third term, what did we multiply by? 2 and 1. So that was, we didn't multiply by 3, we multiplied by 1 smaller, and then down. When we found the fourth term, what did we multiply by? 3, then 2, then 1. So 1 smaller than this is where we started. That's what I've got with this n minus 1. Whatever n is, whatever term I'm trying to find, I start 1 smaller than that, and I multiply by all the whole numbers that are then lower than that as well. I want you guys to see what you can do with part C. Find the first 4 terms and see if you can write the rule for the nth term. What is the second term in the sequence? 32. How did you arrive at 32?
I gave 1/4 of 128.
1/4 times 128. What is the third term in the sequence? 8. How would we arrive at 8? What is our process?
1/4 of 128.
Yeah, 1/4 of 1/4 of 128. We did 1/4 of 32. What is the fourth term in the sequence? 2. What would our process be for arriving at that?
1/4 of 1/4.
Yes. 1/4 of 1/4 of 1/4 of 128. So we have our sequence. First term we were given was 128. When we do 1/4 of that, we get 32. 1/4 of that is 8. 1/4 of that is 2. We could keep going, but we were only asked for the first 4 terms. So what would our rule for the nth term be?
The same.
Hmm?
The same result. It's 128 divided by 4 to the power of n-1.
Yes. So 1/4, or you could have the 4 in the denominator, to the power of n minus 1 multiplied by 128. Or if you wrote it down the way Carrington just said, it would be 128 over 4 to the power of n minus 1. I would accept that as well. That's the exact same thing. What questions do you guys have before we move on to anything else? Yes, sir.
The last one.
Where did I get the last number from?
Yeah, the 1/4 n minus 1.
Where did I get this from?
Yeah.
So here's our process to find the fourth one in the pattern. How many times did we multiply 1/4 by itself? 3 times. So to find the fourth term, we want to multiply this by itself 3 times. To find the third one, how many times did we multiply 1/4? Twice. So 1 less than this is how many times we multiplied the 1/4 by itself. Does that make sense? Okay. What other questions do we have before we go on? Yes, ma'am.
So I had thought it was like 2 times 1/4 and then times 128. So it's not necessarily like 2 times that, it's more like 2 of that K value.
Are you talking about when we put the 1 in here for K?
Yes.
That tells us that we're going to find A sub 2, which is the second term in the sequence.
Okay.
So when you see this right here,
Yeah.
that just means that this number falls second in line.
Okay.
This little 4 right here means that this number falls fourth in line. Does that help?
Yeah.
A little bit?
Yeah.
Whatever that little number is next to this.
Oh, no. I meant like, you know with the 1/4, how for the second term,
Mm-hmm.
you multiplied it twice.
Yes.
So do we do that every time where we multiply that value 2 times? And like for the third term, 3 times?
Not necessarily. Okay, so I think I'm following your question now. To find the second term, we took the first term right here. We multiplied it by 1/4. To find the third term, I take 1/4 and I multiply it by the second term. But this is how we found the second term.
Yes.
To find the fourth term, I'm multiplying 1/4 by the third term. And this is how we found the third term.
Oh, okay.
So I'm just writing down my process here.
Okay, yeah.
Each time I'm taking this and multiplying it by 1/4 to get this number.
Okay,
I took this and I multiplied it by 1/4 to get this number.
yeah.
But to find the pattern so that I can write this down, I need to kind of see how it's growing and how we're building that. Does that make sense?
Yeah, that makes sense.
Okay. If I wasn't asked to write the rule for the nth term, if I was just asked to write these down, I would have taken this, multiplied it by 1/4, write it down. Take this, multiply it by 1/4, write it down.
Oh, okay.
Take this, multiply it by 1/4, write it down.
Okay.
Does that help?
Yeah, that helps.
Okay.
So, Ms. Bo,
Yes.
AFK is always the term that they give you, right?
This is the rule that helps me find the next one. If they had given me A sub 5, the fifth one in the pattern, I could use this to find the sixth one, but I couldn't use it to find the first one. Whatever they give me, this rule lets me find the next one. Does that help? Okay. Most of the time when they give you a recursive definition, which is what this is, they're telling you the first term.
The first term,
The first one in the list.
but it's always the one behind it, right? Behind the term you're looking for.
We can only use a recursive definition to find the next one.
Right.
Yes. So if they tell me the first one, I can find the second one. If they give me the third one, I can't necessarily find the second one. I could find the fourth one, but I can't go backwards. Does that make sense? Okay. I've got 2 more examples that I want to do with the recursive definition. These are a little bit more complicated. We're going to find the first 5 terms, but we're not going to find the rule. So we're just finding terms. What did they give us here? They gave us the first and the second term. Why did they give us both of those? Yeah. Notice this rule for the recursive definition. It doesn't find the very next one. It finds how far ahead. It finds 2 ahead. I'm going to take a 1 and put it in the place of k. And this will allow me to find which term? The third term. So anywhere I see a k, I'm going to replace it with a 1. So I have 3a, and then I'm replacing this k with a 1, plus 1, minus 2a, and then, yeah, I'm putting that 1 in the place of the k there. Are you guys okay with that so far? That piece after the comma where it says for k greater than or equal to 1, do you remember we said that we have to start with the first term? There is no 0th term, just like there's no 0th row in a theater. That's all that is saying. Our k value can't be any smaller than 1. So the third one in this sequence, I'm going to do 3 times which term?
4.
Right here. What is 1 plus 1? Yep, 3 times the second term minus 2 times which term? First term. So let's substitute in. What is our second term? 7. Minus 2 times the first term. What's the first term? 4. 3 times 7 is 21. Minus 8. So what is the third term in this sequence? 13. I want you guys to follow this same pattern. Find the 4th and 5th terms. Find the 4th and 5th terms following the same pattern. What is the 4th term?
Oh, it's 9.
Oh, thank you. I put plus and it's supposed to be minus. Thank you for correcting me. I did it literally everywhere. All right, so now that I have fixed that, what is the fourth term? 25. Fourth term is 25. We take 3 times the third term, which we just found was 13, minus 2 times the second term, which was 7. So 25 is the fourth term. What's the fifth term? 49. You would do 3 times the fourth term. So 3 times 25, which gives us 75, minus 2 times the third term. Our third term was 13, so you're subtracting 26, and that's how we get 49. So far, so good? Let's do one more like this. All right. Should I put 1 in the place of k?
No.
Why not? Because that's going to find a2. Why is that an issue?
You need to find, you already got it.
We already have it. So what should I put in for k then? I should put in 2, because I want to use this to find the third term. So anywhere I see a k, I'm going to put a 2 in. So I'm going to find my third term by taking 2 times my second term plus 3 times which term? First term. So 2 times 2 plus 3 times 1. What is our third term? 7 is our third term. Please find the fourth and fifth. What is the fourth term? 20. That is correct. What about the fifth term? $61. Do you guys need to see how I arrived at 20 and 61? All right. One last thing I want to do with you guys before I pass back your tests. We're going to talk about something called summation notation. This is that kind of E-looking thing, or capital M turned on its side. This is our summation notation. This symbol right here is called a sigma. It's another Greek letter. It gets used for summation. Down here on the bottom where it says k equals 1, this is the index of summation, or the summation variable. They're giving you the first value to substitute into the rule that you've been given. Up on the top, this will be the largest value of the summation variable. So down on the bottom, they tell you the value of the variable to start with. You'll do all the whole numbers in between until you get to the value of the variable up on top. So we're going to start with the bottom. And we will stop with whatever this number is. And we will do all the whole numbers in between. We sometimes want or need to find the sum of many terms of an infinite sequence. This is called a partial sum. Partial because it's not the whole thing. We're taking just some of the terms and adding them together. We can't grab the whole thing because it's an infinite sequence. It never ends. Does that make sense? Okay. Looking at the time, I'm going to get an example in tomorrow. We'll do several examples of this tomorrow. I'm going to pass back your tests now. Okay?